To one and all. We as a student from Department of Triply have done our final year project in improved PMBLDC drive for adjustable speed application. Um, I myself, uh, Master V. Naman, um, going to explain you the project overview and the block diagram. First I'll explain you the block diagram of my project. Uh, I have a power supply, and the power supply has been given to the Atmal microcontroller, and from there I am giving pulses to the pulse generator. Input supply to the pulse generator, and the pulse generator will be generating a square wave pulse for the ECU unit, where the ECU unit has been control everything, controls the motor's speed. So here again see, if the voltage sensor, speed sensor and current sensor, and I have an ADC. So here the sensor senses the speed of the motor, the speed sensor senses the speed of the motor, voltage sensor senses the voltage, and the current sensor senses the current, and sends back to the ECU unit back. If there is any fault occurred in the voltage or in the current, that is high voltage or low voltage or any current related, then the ECU unit detects the voltage and the current, and rectify it by using an error detector, and again sends back to the motor a constant voltage and a current, so that the motor has been protected from the damage, and it has been everything been monitored by the Zigbee in the system. Now I will explain you my circuit diagram. In my circuit diagram, in my hardware kit, it consists of, as I told you, a power supply has been given here, and it consists of a microcontroller and pulse generator, and from the pulse generator the pulses are going to my ECU unit, and ECU unit consists of a microcontroller, CAN bus, error detector, a filter, and a positive voltage supply plus or minus for just rectifying the voltages or a current. So here it consists of a brushless DC motor and a speed proximity sensor, and here I am using a two sensors called voltage sensor and current sensor, and the voltage sensor and the current sensor are voltmeter and voltage transformer and a current transformer. And here we are using a Zigbee module, Zigbee receiver and transmitter. One has been connected to the system, and another one has been connected to the hardware kit, and it has been fully interfaced in the system as shown here. This is my software part. Everything has been monitored over here. Here I can now this is the working model. Now I have been kept my proximity sensor away from my motor, so the speed of the motor shows as 0 over here. The speed of the motor shows over here 0, and the voltage is 220. Current is 124 milliamp. Okay. If I bring this speed sensor, that is proximity sensor, near my motor, then there will be a speed monitor over here. See that? I have bought here, and the speed of that motor has been monitored over here. The speed is 777.5, and it is approximately to the 8000 RPM, because there will be some losses and other things, so it can't be exactly the speed. So if I changes my speed again to a low speed, then my speed sensor changes the speed, and again it shifts to the again it notes the speed, voltage and current. And again, if I change my speed to 500 RPM, the proximity sensor and the voltage sensor, current sensor senses the speeds, and again it sends back to the mic kit. This is my exact working model project. Thank you.